Hi everybody, so this is continuation of tutorial sheet 3 question 5. So we're going to start, last time I ended on question 2, so I'm going to start on question 3. Alright, so question 3 is negative 2 root 3 minus 2i. So first of all, you remember what we were doing in the previous question, in the first part of question 5. You first find r, because the question wants us to convert these into polar form. So you first find r. So r is nothing but the square root of x squared. So my x in this case is negative 2 root 2. That is my x, or negative 2 root 3, sorry. So that is my x, the square of this, and then plus the square of negative 2. So when you find r according to this, you discover that this will be 4 here. 4 times 3, you get 12. So it will be the square root of 12, and then plus, and then the square of 2 is 4. So this is going to give you the square root of 16. Then the square root of 16 we all know to say is 4. So 4 is our magnitude, the magnitude of this vector. Oh, sorry, not a vector, the magnitude of this complex number. Yeah, it's actually also a vector, but in complex form. So we move on. So after finding r, we move on to find the argument. So the argument denoted by arg. So the argument of z. So the argument of z is just given by tan inverse. So tan inverse of y over x. So tan inverse of y over x. Let me just write it properly. So tan inverse of y over x, which is equal to tan inverse of, so my y here is negative 2 over my x is negative 2 root 2. Negative 2 root 2. And then, so as we can see here, this and that can cancel, which gives us tan inverse of 1 over the root of 2. So tan inverse of 1 over the root of 2, your answer you get is, oh sorry, this is not supposed to be root 2, supposed to be root 3. This is root 3. So tan inverse of 1 over root 3, you get your answer to be 30 degrees. So when you look at this angle is in the first quadrant, and sorry, in the first part of question 5 I didn't mention this, so get me clear on this one. So when you are now going to write your z in polar form, before you write it, you first have to look at your angle. This angle here is in first quadrant, it's like this. So that can only go like that. So this angle is in the first quadrant. 30 degrees. And then when you try to plot this complex number on the Argand diagram, on this diagram, you discover that this is the imaginary, this is the imaginary part, or the imaginary axis, and then this is the real axis. So this is the real axis, and then that was the imaginary axis. Then so when you try to plot this, approximately you get your -2 root 2 to be somewhere there, and then you get your -2 in the imaginary axis somewhere there, and hence your complex number will be something like this. So this is going to be your z. Now if you look at this z exactly, it's not if you look at this z here, it's not in the first quadrant, but the angle that we found is in the first quadrant. So there is always this let me just draw it like this. You need to master this. I think I also explained this on trigonometry. So the angles that you use when you are writing these complex numbers are these here. There's this one, there's that one, there's this one, there's also that one. These are the angles that you get. But looking at our complex number here is like it's like this. So meaning we're going to get this one here. Now how do you get this one? So if we've gotten this 30, it means that we're going to move like this. Let me draw first the complex number here. So if my complex number is this, and then I got a 30, so it means that I'm going to move angles always start from the positive x-axis going anti-clockwise direction. So this is how I'm going to move. So this implies that my 30 is there. So this is my 30 degrees instead of it being there. So from there I'll come here and say now that for me to know the angle that I'm going to put in the polar form of my complex number z, already we found the r to be 4. So this r is 4. Then you open brackets. Now the angle that I'm going to put here on cos and on sine should not be 30. It's supposed to be, when I want to find this angle from this point up to that point, I know that this straight line here is equal to 180. So if this straight line is 180, it means that if I want to find the angle from this 0 degrees, from this 0 degrees to my complex number here z, it means that I'm supposed to add 180 plus 30 there. So 180 plus 30, you discover that your answer will be 210. So 210 is the angle that you put there. And then plus I sine 210. So this is now going to be a complex number in polar form. Let's move on to question 4. Question 4 is saying root 2 minus I root 2. So question 4 is going to be root 2 minus I root 4. Root 2 minus I root 2. So first thing you find r. So our r here, when you find the square root of root 2 squared, so root 2 squared plus the this root 2 squared there as well. This is going to give you root 2. So root 2 squared will give you 2. Okay, this squared and this square root will cancel. Then plus, even here root 2 squared will give you the same 2. So 2 plus 2 there, you get the square root of 4. which is just 2. And then you go on now to find the argument. So the argument of z is going to be the same way we write it, tan inverse of y over x. So it will be tan inverse of negative root 2 over root 2. So tan inverse of y over x, which is negative root 2 over 2, which is just the same as tan inverse, to be tan inverse of negative 1. So tan inverse of negative 1, you get your answer to be negative 45. So you're going to get negative 45 degrees. Yeah, so if you want, you can omit this negative and just say tan inverse of 1, you get positive 45. Okay, let's even do that to make things easier. So you get positive 35, but in the actual sense, you know that your answer is negative. Or if you want, you forget about the negatives. Okay, let's go with the method of forgetting about the negatives. So we forget about the negatives, so we get positive 45 as our answer. So now let's try to draw the Argand diagram for this complex number z. So it's going to be like this. Approximately, this is an imaginary axis, and then this is going to be my real axis x. So this is going to be my imaginary axis y. And then let's try to plot this. Approximately root 2 is going to be somewhere there, and then negative root 2 is going to be somewhere there, negative root 2, and then this is going to be my root 2. So meaning my complex number is going to be there like that. So now I've been given the angle to be 45, and then 45, when you look at, if I found this 45 to be positive, then it means that it is somewhere in this quadrant. If I found it to be negative, it's going to be somewhere there. Now if I'm getting the angle, how am I going to get the angle? Because measuring angles, we don't go clockwise direction, no, we always go in the positive, which is the anti-clockwise direction. Yeah, so that is the angle that we are looking for. So how do you calculate this angle? When you are in the third quadrant, you always say 360 when you're finding this angle here. This angle here, 360 minus 360 degrees minus 45 degrees. So when you find that, you discover that your answer will be it's going to be 315. So 315 is the positive angle that you put there. So you write your complex number now in this form. Z is equal to, in the complex form, our R there is 2, so you write your 2 there, then open brackets, then cos 315 degrees, and then plus sine plus I sine 315 degrees. So this is the complex number in polar form for question 4. Let's move on to question 5. So question 5 is negative root 3 plus 4 over, plus 4i. Negative root 3 plus 4i. That is question 5. So in the same way you find you first have to find r. Same way we've been doing these previous questions. Find r. So r is nothing but the square root of this -3 squared, root 3 squared. You find the square root of that, and then plus 4 squared. So when you calculate that, you discover that your answer will be the root of 3 plus 16, which is going to give you the root of 19. So the square root of 19 is our magnitude of this complex number. So let us now find the argument of the complex number. So the argument of the complex number z is going to give you, so the argument is going to be tan inverse. So the argument is going to be tan inverse over y over x, which is 4 over root 3, the root of 3, 4 over negative root of 3. So this is going to be our argument. So now let us try to plot our complex number. We see in which quadrant it's going to be. So it's going to be like this. So approximately my x layer will be this side, will be there negative root 3, and then our y there will be 4i, which is there. I'll put it there, 4. So my complex number is in this direction. Sorry, my complex number will be in this direction. Now if this is my complex number, and then the angle that I've found is this one, so it means that the argument that I'm going to okay, so I think this question, there might have been a mistake looking at the fact that you guys are not allowed to use calculators in the exam. So maybe this was maybe there was also supposed to be a 4 somewhere there, so that at least it comes to cancel with this 4 here, such that when you find the tan inverse of that, we'll be able to find is it 30? Yeah, it would have given us 30. But if they bring such a question there, the way you write it in complex form, you just say, if this question was to come, I mean the way you write it, the way you write this question in the polar form, you write it in this way. So it's going to be, you first write your r, which is the root of 19, and then this one will show you to say my angle will be tan inverse of 4 over negative root 3. So this is how you write it if such a question was to come. Okay, let's move on to question 6. So question 6 is just negative 11. So question 6, the complex number for question 6 is z is equal to negative 11, and then we'll say plus I0 or 0I. So now first of all you find r. When you find r there, r will be negative 11, so negative 11 squared, then plus 0 squared. That is going to be our r. So when you calculate that, you find your answer to be positive 11. Then you find your argument. So the argument of our z is going to be, so the argument of our z there is going to be y over x, so to be 0 over negative 11, so to be tan inverse of y, my y there is 0 over 11. So this is what you're going to get. And then when you find tan inverse of this is just the same as 0 over any number, you get the answer to be 0. So tan inverse of 0, you get your answer to be 0. So your answer is going to be 0. Now let's try to plot this complex number here. It's going to be this. So this is my imaginary axis, and then this is going to be my real axis. So let's approximate negative 11. Negative 11 is going to be somewhere here since it's in the x, so negative 11, then comma 0, comma 0. So comma 0, my 0 will still be in the same line there. So my complex number will be, let me use another color. So my complex number will be in this way, in this direction. So this is my complex number z. So if this is my z, it means that if this is my z, it simply means that the argument there, instead of being 0, because 0 means my complex number was moving in this direction, but since it's moving in that direction, it means that I'm counting the angle from this positive axis going that way up to my complex number, which is equivalent to 180. When you look at this angle, this is 180. This is 180 degrees. So instead of writing 0, I can put 180. So my argument, the argument of z, therefore will be, so the argument of z supposed to be ARG. The argument of z is going to be 180 degrees. So these angles, if you want, you can be writing them in degrees or in radians if they've not specified. So 180 degrees in radians is equal to pi. So at least since I've been writing them in degrees, let me write this one in radians. So this is just the same as pi rad. 180 is just the same as pi in radians. So we move on to the next. Oh, sorry. Let me write it. Let me finish it up. So z is going to be my r there was 11. Then you open brackets, cos pi, then plus I sin pi. So this is going to be my complex number for question 6. Let's move on to question 7. Sorry, question 7 is negative I root 7. So question 7. So question 7 is z is equal to negative I root 7. So for us to know what is our real part there, we just have to put a 0 there so that we don't confuse ourselves. Then we first have to find r as usual. So my r will be nothing but the root of my x squared is 0 squared, and then plus my y squared there is negative the root of 7 squared, so this is going to give us, this is 0 plus this squared and that square inside there will cancel. The negative times negative will get a positive answer, so this is just going to be the root of 7 as our answer. So root of 7 is our magnitude of this complex number. This is supposed to be 7. Yeah. Alright, so we move on to finding the argument. So the argument ARG, so the argument ARG of Z so the argument of Z is going to be tan so it's going to be tan inverse of our y there will be negative root 7 so it is going to be negative root 7 over 0. Then we do like that. So when you find that any number divided by 0, your answer is infinity or undefined. So any number divided by 0, the answer should be undefined. So tan inverse of this undefined is nothing but 90 degrees. Is 90. It's going to be 90 degrees. So after finding 90 degrees, we can now plot the complex number on the Argand diagram. We see in which quadrant it lies. So it's going to be like this. So approximately my 0 is always going to be 0 like that, and then negative root 7 I'll approximate it to be somewhere there. So negative root 7 is somewhere there. Then this simply means that my complex number will be in that form, in that direction. So this is going to be my complex number. So yeah, if this is going to be a complex number, I don't know why my computer just started lagging. Anyway, so if this is going to be your complex number, you can now even tell the angle. So meaning instead of 90, the angle that we're going to have is this. So this angle, this one is 0, 90, 180, this one is 270. So meaning the argument of Z, instead of being 90, it's going to be 270. The argument of Z is going to be 270. So if this is your argument, now you can go further to write your complex number. Your complex number now is going to be in this form. Z is equal to, so Z is going to be equal to, your magnitude there is root 7, and then open brackets, This is going to be cos 270 cos 270 and then plus, it's going to be cos 270 plus I sine 270. So this is going to be your complex number for question 7. So I think we're done with question 5. Thank you very much for watching, and make sure that you don't forget to subscribe to the channel. If you have any questions, any contributions, or any corrections, just in case you find I've made a mistake, I'm also a person I can make mistakes. So even when you are going through the questions, you should make sure that you at least you should make sure that you are at least doing something as well yourself. So thank you very much. Subscribe to the channel, don't forget, so that you don't miss out the videos that I'm going to be posting. So send your questions, contributions, and corrections to this line. Thank you very much.